set number 4. Let us go through the data. So, as you can see, there is some diagram which is given. We will try to understand what this diagram is all about. The above is a schematic diagram of walkways indicated by all the straight lines. So, this is walkway, alright, all of them are walkways, and lakes, 3 of them. So, these 3 are, I suppose, lakes, each in the shape of rectangles shaded in the diagram of a gated area. Different points on the walkway are indicated by letters A through P, as you see here, A, B, C, D, E, F, G, H, so on till P, with distances being OP is 150. So, this is 150. ON equal to MN equal to 300. ML is equal to 400. ML is equal to 400. EL is equal to 200. And DE is equal to 400. So, since this is 400, we could very well say this will also be 400, because these are rectangles, opposite sides will be equal, 400 to 400. Now, since this is rectangle, this will be 90 degree and 90 degree, right, and this will also be 90 degree and 90 degree. So, this is also rectangle basically. So, this will all be 400s. If this is 300, this will all be 300s, 300 all will be 300. So, basically we know, so here we know that each of these blocks will be rectangles and hence opposite sides will be equal. The following additional information about the facilities in the area is known. Point number 1, the only entry exit point is at C. So, this is the entry or exit point, only entry or exit point. Second point, there are many residences within the gated area. All of them are located on the paths AH and ML, with 4 of them being at AH, M and L. AH and ML. So, this is your residential area, AH and ML. And there are houses at AH, M and L. Okay, this is second point. Third, the post office is located at P and bank is located at B. So, post office is here and bank is here, B. That is it. These are the points that we know, and based on this, the first question that we have, 15th one, if you look at it. One resident whose house is located at L. So, he is here at L, needs to visit the post office as well as the bank. Post office here and bank, and the person is starting from here. The house is located at L, needs to visit the post office as well as the bank. What is the minimum distance in meters he has to walk starting from his residence and returning to his residence after visiting both post office and the bank? Minimum distance. So, the way in which he could travel is, observe, from L, suppose he wants to go to post office first, from L he can go to K. Now, at point K there are several paths ahead of him. So, either he can go like this or on this diagonal or on this side, and we know that in a rectangle, if you want to move to the opposite vertex and travel minimum distance, you will have to travel along the diagonal only. And what are the lengths? If you recall, this was 300, this was 400, and hence by Pythagoras theorem can I say this will be 500, and it is better to move along the diagonal than these two sides, because when you move on these two sides you will travel 700. As you can see over here, you are saving 200 meters. Then he will go to post office. So, how much has he covered so far? So, he has covered 300, he has covered 500, here he will cover 150, this was 150 given to us, and now he has to go to bank. So, how can he go to bank? He will go along this distance, this was 400, and from here he will move along the diagonal again, because always remember diagonal would be the shortest, and the question asked us for minimum. What is the minimum distance? So how much will this be? This is 150 and this is 200. I think this was 200 given to us. EL is 200, yes. So 150 and 200, when you will again apply Pythagoras, you will get this as 250. So he will move along this 250 meters. And from G, he will go to B, the bank, 400 meters. And from bank, he will simply move along these lines and come back to. So he will move 300. Then he will move again, this is also 300. And this is 400. And this is 200. So this will be the shortest path that he can travel on. So let's add up all the values to get to our answer. So when you add up 300 and 500, 800, 800 and 150 is 950, 1350, 1600, 2000, 2300, 2300 and 300 is 2600, 2600 and 400 is 3000 and 200. So 3200 is the minimum distance that will be travelled. So option choice 4 should be the correct answer, and this is the path that the person will move on. And since he said minimum, we'll have to ensure that wherever possible, we'll move on the diagonal. Next one, 16.1. One person enters a gated area and decides to walk as much as possible before leaving the area without walking along any path more than once and always walking next to one of the lakes. So there are some restrictions that he has. So there is a person who has entered the gated area, so that means he will enter here only. This is the only entry point, C. And decides to walk as much as possible before leaving the area without walking along any path more than once. So you cannot repeat a path. Always walking next to one of the lakes. So that means they can move along these paths only. Okay, these paths only. Note that he may cross a point multiple times. So a point can be crossed multiple times, but a path should not be crossed multiple times, not even twice. How much distance in meters will he walk within the gated area? So he wants to travel as much as possible. So let's try to maximize the distance he can travel. So he comes to C, he will always have to move along the lake. So if you look at it, I'll just write down the distances: 400, this is 300, 400, this is again 300, this is 200, 300, 300, likewise this is 400, 400, 300. See, we should not miss the 400 meter segments because they are the longest that we have. And this is 200, of course, this is also 200. So let's see how he can move. So he could move as follows. From C, he can go to D, then he can go to E, then he can go to F. From F, either he could go like this, right? Either he could go like this, or he could also go like this. He could go here, then he travels like this, then like this. He can come to a point several times. Path should not be repeated, but point can be repeated. From K, he will go like this, like this. Again, he can come to F, and then he can move out. So basically, he is able to cover, if you look at it, all the sides of these three rectangles. He is able to cover all of them. So thus can I say the distance travelled by him, maximum distance travelled by him will be nothing but sum of the perimeters of these three rectangles. So how much will that turn out to be? 800 and 600, 1400 for the first rectangle. Second rectangle 400 and 600, 1000, and here again it's 1400. So when you add it all, you will get 3800 as your answer. So the person can travel for a maximum of, because he says he wants to travel as much as possible, so he can travel this much, 3800. So option choice 4 should be the correct answer. 17th one, one resident takes a walk within the gated area. So he is a resident, right? Starting from A. So starts here and returning to A without going through any point other than A more than once. What is the maximum distance she can walk in this way? So if you look at the initial conditions, we can move along any path. Let us 1 second. Gate area is given as the distance. The following additional information about the facilities in the area is known. The only entry point is this. One resident takes a walk within the gated area starting from A and returning to A without going through any point more than once. See, please remember the previous condition was without crossing a path twice, multiple times. We could cross points multiple times in the previous question, in this question. A point can be crossed multiple times, but here even that is to be avoided. So we cannot go through any point multiple times. What is the maximum distance that she can travel this way? So she is starting from A. So starts from A. So I have to get back to A. But please again remember, these distances are 400. And these distances are 300. Similarly, this 400, this 200. I don't want to miss out on the 400 distance. Alright, I will try to ensure that I cover the 400 distance. How can she move here? So here from A and getting back to A without crossing a point more than once. Let us try to do it this way. So probably we can go from A to B, and from B we have two paths. We could either go on BC or we could go on BG. So which is better, BC or BG is better? I think it is better we go on BG because BG is longer as compared to BC. BC is 300, BG is 400. Now from here we could go to GF. So this is 300. So we are moving like this, and from F we could again go to C. So we are skipping this BC path out there, right? From C we can go to D. Sorry, it is not 150, this is 300. Let me change that. This is 300. And from D, go to E. I cannot come back to F because then F will be, the point F will be crossed multiple times. I cannot come back to F. From E, we will go to L. And please note, from L, we cannot go to M because I think, so sorry, here we can go to M. So from L, we could either go to K, which will be 300, or we could go to M, which will be 400. I will prefer 400. From M, we can only go to N. From N, we could either continue like this or go like this. I will prefer this because this is longer. From K, we will go like this. From J, again we can go like this. From O, we can go like this without crossing a point because I cannot go backwards. I can go to P only. From P, we can only go one way. From I now, we can only go to H, and from H, I can only go to A. So this could be, I think, the maximum path. Let us add up the distances and see how much do we get. So this is 150 and 400. Let us add it slowly. It is 550. 550 and 300 is 850. 850 and 400 is 1250. And 300 is 1550. 400 is 1950. Or if you want, we could also, okay, let us continue like this. 1950 and 200, 2150, 400, 2550, 300, 2850, 400, 3250, 3550, 3950, and this is 4100 so far, till here 4100, and from here to here it is 400, 4000. So 5100 is the maximum distance that she can travel. All the paths that she has moved on, I have highlighted it and also circled the numbers, the distances. So it will be 5100 when you add them all. So which option choice will it be? Okay, we do not have options. So he's asking us the maximum distance in meters. We'll write 5100. That should be our answer for this question. And this is a path that she can take. 18th one. Visitors coming for morning walks are allowed to enter as long as they do not pass by any of the residences. And where do we have the residences? We have the residences here. We have the residences on AH, so they are not allowed here, and we have residences on ML, they are not allowed here also. And do not cross any point except C more than once. So similar condition like the previous, the point cannot be crossed multiple times. What's the maximum distance such that a visitor can walk within the gated area? What can be the maximum distance? So they are starting at C, and again I will try to not miss on the 400 meter distances. I will ensure that I will try to cover them. 300, probably we could miss. If you have to choose between 300 and 400, I will miss 300 and choose 400. Okay, let us see how can they move. From C, after entering, they can either move to D or F. So let us say they move on D, 300, because I can cover the CF distance while coming back. From D, I can go to E. From E, I could go to F, or I could also go to L. So which will be better? Let's see, just a minute. So I will go to L for now, suppose. From L, I cannot go on this path, I will go to K. Okay. From K, I will go to N, because I want to maximize my distance as much as possible. From N, I will go to O. From O, we can go to P. From P, I can go to I. From I, we could go to H. From H, we could go to G. From G, we could go to F, and from F, we could go to C. This could be the path. So in this path, if you see, we are missing out on this 200 meters. That's okay. We are missing out on this 200. Can there be an alternate path? Let's try to draw an alternate path if possible. One more could be, suppose I go from C to D, D to E, E to F, okay, and from F to K, and K I cannot go to L, I will have to go to N. From N, I will go to O to P, correct. From P, I can go to I and then H. From here, I can go to G. From G, I can go to B and then to C. We can also exit like this. Let us try to see in which case are we getting the distance maximum. So if I count the first path, so it will be 300 and 400, 700, 700 and 200, 900, 900 and this is 300, 1200, 1200 and 400 is 1600, 1600 and this is also 300, 1900, 1900 and 300, these two together, 2200, 22 and 400, 26, 2800, 2800 and this is how much, 300, 3100 and 400, 3500 is what I am getting over the red path. Let me also just check the blue path, is it the same by any chance? Most likely it could be same also, because we are just moving on parallel segments, instead of moving on FC, we are moving on GB. So I guess it will be same, let us add it anyways. So 300 and 400, 700, 700 and 300 is 1000, okay, 1000, 1000 and this is 200, 1200, 1600, 1900, 2200, 2200 and these two, 2600, 2600 and this is 3000, 3300, we are getting 200 less over B. Which part did we miss? we are getting 300 less, I think. 1 second. Over the blue path, 300 and 400, 700, 1000, 1200, 1600, 1900, 2200, 2200 and 600 is 2800. No, it's same. We are not missing anything. We are getting same 3500 there also. So, the maximum distance that we can take, there could be two different paths, but the maximum distance that the visitor will walk can be 3500 meters. Cannot be more than that, because on account of the given conditions that they cannot cross a point multiple times, they cannot even walk on this residential areas. So, this is a path, the two paths, the blue path and the red path, both are acceptable. So, with this we are done with the fourth set.